Good morning, everyone, and welcome to our training session on statistical data analysis with a Python for research excellence. We are delighted to have all of you joining us for the meaningful learning opportunity. Today, we are honored to have Associate Professor Dr. Pongprapan Pongsophon from the Faculty of Education, Kasetsart University, who will sharing his knowledge and expertise in the field of statistical data analysis and the use of Python for advancing research excellence. Before we begin, please make sure that your audio and video settings are working properly. If you encounter any technical issue or have questions during the session, feel free to use the chat box to contact our team. And moreover, we encourage you to actively participate and make the most out of today's training. And now, without further delay, let's begin the session. Please join me in welcoming Associate Professor Dr. Pongprapan Pongsophon to start today's presentation. Dr. Pongprapan, please welcome.
Hello, my name is Pongprapan. I come from Kasetsart University, and this is really my first time to conduct a online training for Python for data analysis. Usually, I conduct this kind of workshop on site, so I know it will be challenging for many of you, including me, because we have to, sometimes we cannot keep up with the with the lecture, and I myself could not physically help you when you got stuck when you write the script. And but however, I will do my best. So if you get stuck with any technical difficulty, just let me know in your comments box. Okay. Now I assume that you have already print out the worksheet. Actually, the worksheet is a script of the code. Okay, so you don't need to worry about the code that I will put on the screen. You just look at your handout, and I already put on it the page, the number of page, and also the line number. So I will refer the code that I'm working on that page and that line. Okay, and let's start. Just let you know in now that we don't need to install any software, because right now Google developed a platform to write and run Python. Okay, and that is called Google Colab. Okay, so I'm gonna share your screen how to use Google Colab. Okay. Okay. So you can see this is the google.com, right? You type Google Colab. Okay, that is just one L. Okay, not double L. So Google Colab. Okay, and then okay, the first hit in the list is the Google Colab. Okay, you just click on it. Okay, actually, it will ask you to log in. Okay, all of you need to have a Google account, and you log in first. And once you log in successfully, you see your face on the screen. Okay, and I'll give you 10 seconds, okay, to log in using your Google account. Okay. Okay. Um, Once you log in, you're gonna see the tag, the blue tag with the letter plus new notebook. Okay, you click on it. Okay. Okay, it will take you to the new notebook, and you see that there isn't a name of the file yet. So you just rename it, maybe something called แม่ฟ้าหลวง University. Um, one, okay. แม่ฟ้าหลวง underscore one, okay. And please turn on your handout on page 2, line number 1 and line number 2. So we're gonna install packages, okay. What does it mean by package? Package is a set of function that collaboratively designed to do specific challenging and difficult tasks. And once you have the package, it will make things a lot easier. Okay, so how to install the package? Okay, is on line number 2 on page 2. Okay, you type, okay, this signed, and you put pip install Seaborn. This is the name of the packages. Okay, stat model. Okay, and open PyXL. Okay. You have to be very concise. No, precise. Okay. Be aware of typo. Okay. Seaborn stats models. Okay, don't forget to put S after the name of the stat model, and open PyXL. Okay. So let me talk a little bit about our package. Seaborn is where is generally used for create illustration or visualization. Okay, and for the stat models is as the name imply, is about statistical function. Okay, when you want to analyze something, okay, you're gonna use function in this package. And the open PyXL, XL, you can guess, is this the Excel? Okay, sometimes we have to work with the real data, and the data that we collected, we usually um, um, put it on Excel file. Okay, so if you would like to import the Excel file and read the file, okay, you need to use the Open PyXL. Okay, so you see there is a circle with the triangle inside. This is the run button. Okay, you click, and you can see that it takes some time because we use the Google Lab, which is it will connect with the cloud uh, cloud base. So we don't need to, and you can see that they are saving auto save from time to time. Okay, and right now we successfully install the package, the 3 packages: Simon, stat models, and OpenPy XL. Okay, and I want you to go down, and you see that this is the border, okay, of the first block of code. Okay, block here is the area that you are working on. You can have many blocks, okay, and at the bottom, at the border, the border at the bottom of the box, okay, you just drag, no, not drag, you just move your mouse over the border line, and you see that there is a two button pop up. One is plus code and the other one is plus text. Okay, you click on plus code, and you see that you have a new block code. Okay, so we will import, okay, import numpy, okay, as np, and import pandas as pd. Okay, so usually these two packages, by default it already installed in the Google Colab. Okay, so as here, meaning that you don't need to type it full name of the package. You just put this is the abbreviation. Okay, for the numpy, okay, we just print you just type np. Okay, for the pandas you just type pd. Okay, for the numpy, most of the time of our time we have to calculate. Okay, we have to do something with a number. Okay, the operation, for example, we're going to use numpy a lot. For the pandas, it work well with the data structure, which is a data frame. Okay, or something with two dimension structure, okay, like table. Okay, you're gonna use PD. Okay, so very first we're gonna create a set of data, okay, randomly. Okay, when I say random, okay, my data set might be different from you and you with your colleague or your friend here, your whole from another person here in this workshop might be different. Okay, because we random. Okay, but if you would like to set and make sure everyone have this exactly the same data set, okay, even we random it, okay, we need to get the same starting point. So we have to use numpy and random and seed, and we're gonna have a code, okay, which is a number. Okay, and we need to set it the same, which is for to, it can be any number, but we have to use the same number to ensure that after we randomly create the data set, we're gonna get the same data set. Okay, we get the same values. Okay, okay, once again, np.random.seed. This is done to ensure that the data set we randomly create will end with the same data set. Okay. Then, okay, we will create the data set. Okay, we name the data set data. Okay, and for those who might not familiar with Python, okay, we have the term called object. Okay, object. I would like you to imagine is just a box, okay, that contains something on the right of the equal sign. Okay, so NP random rand int. Okay, and 100 and size equal 10 and as type. I'm gonna explain it in full shortly, but right now just type is on line number 12 on page 2. Okay, data equal NP or numpy dot random dot rand int. Okay, and we're gonna make our value, okay, between 0 to 100, which is the min and the max possible. Okay, and we need to have a sample size at 10, and we want the value to be float. Float here is mean decimal. Okay, decimal. Okay, so you can print it out actually. Okay, it's not on the worksheet, but in case you need to see the number, just print and put your object data in between parentheses. Okay, and you click run. So you're gonna see we have 51, 92, 14, 71, 16, on and on to 74. Okay. Do we get the same set of data set? Same set of number? Okay. Everyone should get the same because we set the starting point at 42. Okay. So I'm gonna remove, okay, I'm gonna remove this line. Okay, it's just done to show you the data. Okay, you can skip that particular line by using the sharp sign. Okay, you put it in the front of the line, so the program will skip and read the next line automatically. Okay, and now sometimes when we collect the data, it always happen that we're gonna have missing value. Okay, sometimes the respondent or your participant will skip that that item. Okay, if you don't force him or her to complete the form, they have their right to skip. Okay, and sometimes it's come from the researcher him or herself that, okay, sometimes I put the value in Excel, and you know, sometimes because of the you know, human error, we forget to put in the number into the cell. Okay, and for that cell you don't have any number, and we call missing value. Okay, so we're gonna randomly create the intake index. Okay, index here is mean position. Okay, position in the data set that we're gonna make it the missing value. Okay, so we I think I need to enlarge the screen, make it larger so you can see it more clearly. Okay, missing. Okay, index, okay, equal to, again, numpy random, and this time choice. Okay, because we have from the data we have 10 values. So we have the scope. Okay, we have the scope, range. Okay, and this is a sample size which is 10. Okay, and we want our size of our missing value to be 3. So there will be 3 missing values. Okay, and 3, and we will not put it back. Okay, when we random something or just random number, okay, you have 2 choice to make. You can replace. It means that you will put it back into the pool, or you just take it off. Okay, so replace with put false. Okay, so what I'm doing here, okay, what I'm doing here, I create another object called missing index. Okay, and this one, okay, I will create, okay, an index or the position of of um, of the missing value. Okay, from 1 to 10, this is the sample size, okay, that we create previously, and we want to have 3 missing values, and we won't put back that value into the pool. Okay, so if you want to know, okay, which position, okay, that will have the missing value, you can print it out again. Missing index. So at the position 0 in computer science, the first position is the index 0. Okay, and the index 7, which is the 7 actually, and the last one, which is the 9. Okay, the 9's index, meaning over here. Okay, over here we will make it disappear. Okay, disappear as a missing value, so it will be gone at the first, and over here I think, and this one. Okay, all of those value will be gone, and they will be a missing value. Okay, so we will make that data with the missing value. Okay, so you will have a square bracket and missing index. Okay, missing index, and equal to numpy nan. Nan mean missing value. Okay, so this one mean that for your data set, which has a sample size at 10, okay, we're gonna make the position, the index 0, index 6, and index 9 missing. Okay, okay, let's do it. Okay, and if you want to see, okay, what it gonna be look like after we replace the real value with missing value. Okay, you can see that the first position, okay, which is index 0, and this one, which is index 6, okay, at 82 will be gone. And the last one, okay, at the position 10 or index 9, it will be has already gone. Okay, so what we're gonna do, okay, in this case, we will replace missing value with something acceptable. Okay, here it should be mean, median, or mode. Okay, so we will create another object called S. Okay, and we will create CVs. Okay, CVs, and we create. No, we don't create. We will put our data set. Okay, which has 3 missing value. Okay, and then we gonna I think I have already print out the data set with missing value already. We can skip this line that the line of 20, the line 20, we can skip it off. Okay, so we will move to okay, we move to print it on line 23. Okay, print, and then and then this one backslash n mean we will put an enter or an empty line before. Okay, and we have a text called missing value count. Okay, and we will have s is now sum. Okay, so what happening here? Okay, I create a new object called s and equal to PD and CV. CV is like a vector of the data. Is a kind of data structure. Okay, it's a linear, and it is a sequence of values. Okay, and on this line I'm gonna print out, okay, the word. Okay, the word, if you have the word, okay, you have to surround it by the quotation mark, and then you're gonna print, okay, the object s is now here is mean missing value, and you're gonna sum missing value, and hopefully it will give you 3. Okay, you run. Okay, you see that the missing value 3. Okay, so over here, and the last one. Okay, so 1, 2, 3. So now this is the very simple way and usual way to check the how many missing value you have in the data set. Okay, so we're gonna do something, handle the data data set with missing value. Okay, first off, we need to have another object called meanwhile. Okay, meanwhile equal to s mean. Okay, this one mean that this is your object, and this is the method, or it's a kind of function, okay, that you're gonna do with the number, okay, or the value within s. Okay, so we're gonna make a missing value from a variable 7 value, okay? And then we're gonna create a new, okay, a new object called s underscore field s field na with mean well, okay? So this is another object, and this time this object has an na replaced by the mean, which is already calculated in the previous line over here, okay? Okay, please turn on to page 3. Okay, so we're gonna print is on the second line on your handout. It's on page 3, and line number 2, print backslash to make it read more easily, data after mean imputation. Imputation here mean you replace the missing value with some good and best representative value, which is the central tendency. It could be either mean, median, or mode. And we have to put the backslash n. Backslash n is just give more empty line into your output, and print s field. All right, and you click run. Okay, if things go right, okay, you can see that you will have a thick green tick mark here. Okay, so let's see. And I need to zoom out. Okay, you see that at the index 0, which is position number 1, and index 7, which is the position number 7, and the last position, okay, with index 9, it already is used to be a missing value, but now it's imputed. Okay, it's imputed with the same value, which is the mean of the remaining 7 values. Okay, 59 dot something. Okay, the same across. So this is the way we make something called data cleaning. Okay, right. Okay, we're gonna move to something fun. Okay, something more fun. Okay, please turn on page number 4, and please look at line number 7 and 8. Okay, we're gonna make a new code box. Okay, and we're gonna import Seaborn. Remember, we have already installed Seaborn. Okay, as SNS and import pandas as PD. Okay, and we will gonna have a df. Okay, the df is an object. Okay, and it is a good name. Why I said so is a good name? Because For the statistical software, okay, we usually name an object. DF is abbreviate from, or it stands for data frame. Okay, so you're gonna see data in the frame very soon. Okay, equal seaborn and load. Okay, seaborn not very good at data visualization, but is also uh, 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 a set of very good data set for practice. Okay, we're gonna download data set Titanic. Okay, Titanic. Okay, anyone know what Titanic mean? Okay, I'm not sure whether you watch the film Titanic or not. Okay, it it is a tragedy. Okay, it's a tragedy. The leading role is Leonardo. I could not remember his family name or surname, but it's a romantic tragedy. Okay, but it built it make from the real event. Okay, this is the cruise that sunk in a river. Okay, and so many people die in that event. Okay, and when you have any data, you need to see the data structure or metadata. Okay, so what we're gonna do is we're gonna do df info. I will zoom in. df info, right, and we click run. Okay, so it's gonna tell you that there is 891 records or entries. Okay, and this is the index. Okay, in a computer it start at 0. Okay, and we have column. Okay, you can name it as a variable, that's fine. Okay, we have survive, p class, on and on to alone. Okay, and some information. Okay, here int stand for integer. Okay, integer mean whole number. Okay, for the object, okay, it mean like a category, like you know, sex can be either male, female, or unidentified. Okay, for the age, okay, it makes sense. It could be a 4 because our age can be like 25.5, meaning that guy 25 years of age with 6 months old. Okay, and something like this. Okay, and once you know the metadata or the data structure, okay, we're gonna see we're gonna send comment it out. Okay, by putting the chart in front of the line, so the program will skip that line. Okay, we're gonna put df. Okay, df head, so it's gonna show you the first 5 rows. Okay, you see this is the first 5 row. Okay, and this is, you see, 0, 1, 2, 3, 4. This is the index. Okay, and this is the record number 1, number 2, number 3, number 4, and number 5. Okay, and this is the class. Okay, the class here I think is like a railway train. For the third class, is maybe cheapest. Okay, for the first class, obviously, if you go to the first class on the train or in the airplane, you pay the most expensive. Okay, the big amount of money. And the sex here, male and female, understandable. Okay, and this is the age. You can see that it could be decimal because it's already declared that this column is the float and this is sibling. Okay, and what next? Okay, we're gonna comment out again. We don't want to see the first 5 row anymore, so we're going to remove it by comment out, by put the sign, the sharp sign in front of the line. Okay, and we're going to make df. Okay, df, describe. Okay, describe. Okay, describe here stand for descriptive stat. Okay, descriptive stat, you just describe the data about the mean, the median, or what else? The max and min, something like that. Okay, you click. Okay, you see that. Okay, we have 181 entries. Okay, and this is the mean, this is the standard deviation, this is how spread the data from the mean. We have mean, we have the first quartile, we have a median, we have the third quartile, we have the max. Okay, but the thing that bother me a lot is P class. As you know, for this one is according to the measurement. Okay, the level of measurement, the P class is the ordinal level. Okay, meaning that you have category, and that particular category is a rate higher or lower than other. Okay, but you cannot find mean from that. It's like, you know, this year, okay, Miss Universe, okay, they announced that there are five finalists, and you try to make the mean out of the beautiness, which is nonsense. Okay, what best we can do, we can order or sort it. Okay, uh, by value decently or descent or ascendingly. Okay, okay, for the first, second, third, or the fifth, or the fourth, and the third, and the second, and the first, or the Miss Universe. But you cannot, make a mean or a standard deviation with this kind of ordinal number. And in the very soon, I gonna share you tip how to make change the level of a measurement from this one. Okay, because it show the number. Okay, so the machine don't know that is actually the ordinal number, but we need to make them know. Okay, and I will teach you shortly. Okay, and what else? Okay, sometimes, okay, by accident, or or maybe something happened with the machine. The machine here, I mean the computer. Okay, we have a duplicate. Okay, duplicate mean identical. Okay, you have identical uh, identical identical record. Okay, which is an error. Okay, in order to make sure that there is no duplicate. Okay, we need to drop the duplicate. Okay, so we're gonna make we're gonna use the same object named df, and we use the method dot duplicate. Okay, duplicate. Okay, okay, and okay, you see that after remove the duplicate, okay, the record decrease from 80 something to 784. Okay, so there are a lot of duplicate here. Okay, what we're gonna do next, even we remove the duplicate, okay, for any record or entry, it's possible that there is a missing value, right? So we need to check. Okay, we need to check. Okay, so we're gonna print df is now sum. Okay, so we're gonna count the missing value in this data set regardless the variable or the column, any column that or any record that has a missing value, we're gonna count. Okay, so you see that we have a missing value at the column name age with 106 and 6, and we have the deck, okay, 582. Okay, so what we're gonna do, okay, what we're gonna do, please turn on page 5. Okay. I think we have already print out the number of duplicate row already, right? 700 something. So we can skip the syntax from page number 5. Okay. Okay, and you see that if you turn on page 6, you get the same result. Okay, the number of row after remove duplicate is 782. Is on page 6 at line number 18. Okay, so we gonna um we're gonna make a new code blocks. Okay. Right now I'm on page 6. Okay, and we were gonna do something called data manipulation. Okay, we do the data screening, data cleaning, and this time around we're gonna do data manipulation. Okay, the manipulation is mean that we manipulate the data. Okay, we will change, we will transform, okay, the data to make it ready for the next step, which is the analysis. Okay, I'm gonna create. Okay, actually in the handout they use df, but I'm gonna use df2 because if you use df, it will overwrite the df in the previous box. Okay, so df2 it's come from df. Oh, okay, and you're gonna select. Okay, you're gonna select some variable that you are interested in. Okay, so in this case, survive p class, sex, age, fair, and embark. Okay, and for this one we don't need to make a copy. Okay, in the hand in the handbook handout. Okay, you see that I will end this with dot copy, but this time we don't need to copy anything because we already changed the name of the object. So the machine, you see that we have two different object, df and df2. Okay, and this is the way we select the data. You need to have the original data set, and you need to have a double bracket, and you put the name of the column or the name of the variable. Okay, you're just interested in 1 2 3 4 5 6, just 6 column or 6 variable. Okay, so we're gonna check it out. Okay, by print selected column, and then df2. Okay, df2 column to list, and we will add an empty line, \n. Okay, ooh. Okay, this is a very good example. Okay, very good example of an error message. So don't be afraid, don't be afraid. Okay, just okay, it will show you that you have do something wrong. Embark actually has an ed. Okay, okay, so this is the selected column, this is the output, survive p class, sex, age, fair, and embark. Okay, so please turn on page 7. Okay, turn on page 7. So there are some cases that we interested to analyze in the subsample. Okay, like if you have male and female, you only interest for the female sample. Okay, what we're gonna do with that? How we're gonna do? Okay, so you turn on page 7 and on line number 2. Okay, we're gonna create DF2. Okay, DF2, not DF female, DF2. Okay, it's come from this one. Okay, this is another new object. Okay, and we, okay, DF2, you can see that sometimes it suggests us the code, okay, to do, okay, because this is the advantages of one of the advantages to use the Google Colab, because they have an AI here and they can remember the pattern, okay, and they can suggest us and it will save us time. But anyway, for the beginner just like us or some of you, I still want you to write on your own and try to understand the meaning of the syntax. Okay, so the F here is mean the object, and the F sex here mean that you look into the variable sex, and that value that you want is female. Okay, so this is the way you filter. Okay, this is a very common term. Okay, you use the select to select column or variable, and you use filter to select a particular value. For here, okay, you select female subsample. Okay, so okay, we're gonna print out. Okay, we're gonna print out. Okay, this one is interesting. It's called print f string. Called print f string. And why it has to have the f string? The f string can contain the text. Okay, and also placeholder. Okay, which I'm gonna show you shortly. The number of female passengers. Okay, length, female DF, female, and person, and empty line. Okay, you can see that there is a wavy line under, so it fact there is something wrong here. Okay, so I need to check. I forgot to put 2. Okay, it's look fine, and you click run. So among 700 data point, okay, there is 283, okay, female in the data set. Okay, so what next? Okay, remember that I promise that I'm gonna show you how to change the level of measurement. Okay, if you want to check data to female info, you see that for the P class, for example, okay, it is in integer, which is the whole number. Okay, so when you do the descriptive stat, it will aggregate the values by mean or median, which is not make sense. Okay, same with the sex. I'm not sure whether it is declared as an object, but it should be a category. And a category here mean either nominal or ordinal, nominal or ordinal. Okay, so this is this line of code I'm gonna show you. It won't be in it isn't there isn't in your handbook, but I just want to show you how. Okay, I will how to change the level of measurement. Okay, I will cancel out not cancel out, comment out, so the computer will skip those lines. Okay, and we need to have okay, this line and the next line, you want you don't see it in your handout. I just give it in addition. Okay, just for demonstration. Okay, so let's do the survive first. Okay, the survive df2, right? df2 female, and you select the variable survive. Okay, and then df2 female and survive. Okay, dot as type. Okay, category. Okay, category. Okay, once again, you have to select. Okay, you have to select the variable that you're interested in, and then equal to that column. And this one, okay, is gonna change from numeric, okay, to category. Okay, for the survive, it's possible that you survive or you didn't survive, meaning you die in the event, right? And you put as type category. Okay, as type category. Okay, you click, and then the F2 female, oh, info. You see, for the survive, it's change. It change. Okay, from int, okay, from int to category. Okay, so if you okay, comment out. If you do print to okay, survive, where survive. Okay, let me fix. Okay, I need to print it. Okay, okay. You see that they will not calculate. Okay, they will not calculate the mean anymore. Okay, but what they do, they say that okay, there are two unique value possible, which is survive and not survive. Okay, and for the first here, okay, it is the I guess is not survive. Okay, so that's why it's called is dominated. Okay, um value. Okay, so for the 207 survive, so it will do frequency. You see the frequency for us. Okay, so rather than find the mean, the median, the standard deviation, what they're gonna do, they will count. Okay, they will count, and then they will show us that how many value that are different. Okay, and then they're gonna show you the for the uh, dominant value, which is 1, and I guess is not survive or die in the event. There are 217 person. Okay, So this is like how you change, okay, change the level of measurement, okay, from numeric, okay, or interval or ratio into nominal. In this case, it's called category. Okay, so I will do it for the sex. Okay, for the sex. Okay, it do the same, and we just change this to sex as type category. Okay, and we're gonna okay. So you see that for we have survive now in the category, okay, which is the nominal or ordinal, okay, and for the sex, which consists of male, female, or unidentified, okay. Sometimes they feel uncomfortable to identify themselves by certain sex. They can tick, or they can just give information that I don't want to identify myself as female or male. Okay, just put it unidentified. Okay, that is the third category. Okay, so it changed, okay, to category. Okay, and again, um for the sex, okay, for the sex, okay, and you see that um among among let me check. And this is okay, this is the survive, and this is the sex. Okay, and we don't surprise, because this data set already filter, right, already filter all of the sub sample, uh they are female. So that's why when they count, okay, they count, the total is 263, and there is just one possible value, which is 1, meaning female. Okay, and all of the value female. Okay, this is frequency of 1 or female. Okay, I hope you understand. Okay, this is how we change the level of measurement from um, interval or ratio to ordinal or nominal. Okay. Okay, and before we take a break, okay, I'm gonna show you something called pivot. Okay, pivot table. Okay, and pivot is a kind of descriptive stat. okay, it is analyzed to some level, and it also used as a visualization in a form of table. Okay, so just for before the morning break, okay, we're gonna do the pivot. Okay, so please turn to page 8, page 8. Okay, and you move up your box, okay, and you mouse over the border bottom line, and you see the 2 button here. Okay, you click plus code. Okay, and then we will be on line 10. Line 10. No, I don't think that my my line is the same as yours, because I add the change level of measurement inside my note. Okay, anyway, just follow your version. Okay, it start with pivot. Okay, pivot. Okay, pivot. Let me check with your original version. I think I realized that mine is slightly different from yours. So in order to help you with me, I need to have your version. Okay, let's see. Okay. All right. For your version is okay, I see it. Okay. It on page 7, your in your handbook. Okay, in your handout, sorry, in your handout is on page 7, and on the line 5, number 5, pivot. Okay, equal. Okay, this time is a df female. Okay, df2 female. No, df, the original one, okay, df pivot. Okay, table, and index embark. Okay, so type it carefully. Okay, do not remember, don't remember, don't forget don't forget to add ed at the end of embark, otherwise you will get an error message. Okay, and column sex, and the values. Ooh, it's fair. Okay, and act func. There are a lot of pop-up. Func equal mean, and then we print out. Ooh, then we print out pivot. Okay, table average. fair. Pivot. And empty line. Add an empty line at the end. Okay. So we gonna make two-dimensional data frame. Okay, we use two variable. Okay, embark and sex. Okay, and embark here is mean where you get on and off the boat. Okay, and the sex here is a gender, male and female, and the fare here, okay, it will show you at uh, it will show you that for the particular uh, uh, embark for a certain sex, what fare on average you pay. Okay, this is what the pivot table look like. Okay, this is the embark C, Q, and S. This is a male, female, and this one mean that for the embark C, if you're female, you on average you pay um 76 something. Okay, but if you male, okay, if you male, you pay cheaper. Okay, you pay cheaper. I don't know the story behind this, but the 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 male pay less. Okay, on average. Okay, Q and S the same. Okay, so this is if 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 you were asked, okay, I just want to know for a particular embark for certain age, how much on average they pay. So you can use this syntax to create pivot table. Okay, you see that they rather than they put on the same line, they will enter. Okay, enter. Okay, and this is the enter again and create like the empty line to make it easier to read. Okay, so okay, we will take a short break for 10 minutes. Okay, now it's 10 33. Okay, 10:34. 10:34. Please come back on 10:35. Is it okay for 10 minutes? Okay. So again, if you have any problem and if I speak too fast or type too fast, just let me know. Okay. So take a short break for 10 minutes and come back at 10:35. Okay. Everyone is ready. I'm welcome to the training online training session. Okay. I think we have done as planned, which is good. Okay, so next step, we're gonna make a new block code. Okay, and we will create something called long format. Okay, long format. Okay. Oop. Okay, you go to okay, the last code box, okay, and you mouse over the line, and you're gonna see two buttons. Okay, you click plus code, okay, and we're gonna do convert, okay, convert to long format. Okay, usually when we think of table, we're gonna usually and mostly see the data presented in a Y format, meaning that you have the column, okay, you have many column, and you have a value of each ID or each record. Okay, now we're gonna do something with the format of the data set. Okay, we're gonna make it long format. Okay, you're gonna see shortly, okay, what it's like. Okay, now you create a new object called df melt. Okay, melted. Okay, and then you use df melt and id variables is sex. Okay, and values. Okay, values here RH and fair. Okay, oh, yes. Then I'm gonna print out to show you example of long format data and enter. You need to put quotation mark because this is text. Okay, and you enter, then you show df format A, and then enter again, and you close parenthesis. This is a print. Okay, so let me explain to you what does it mean by the first line here. Okay, we create a new object named df underscore melted. Okay, and this one will make the data format to be a long. Okay, normally we're gonna see it Y. Okay, now we're gonna see it long. So we will see and you will understand. Okay, at first, okay, we need to use the method melt, and we have to give information which variable will be the ID. Okay, and which variable will be the value. Okay, will be the value. Okay, so we're gonna click here, run. Okay, this is show you when you use the head. Okay, it will show you the first, okay, the first 5 rows. Okay, you see that For the male, female, this is from different person. Okay, this is the ID, sex as an ID, and the variable here is the age. Okay, normally we're gonna see age in the column, and we have its value in the record, right? That is a Y format. Okay, and I will gonna increase this to 800. Okay, you see that? Okay, for the fair, okay, age and fair, they're gonna be a long format. Okay, for the female fair, this is the value of the fair. Okay, for this female, okay, just like this is called long format. Okay, and why we need to have a long format, many statistics require the long format data structure. Okay, such as ANOVA, okay, ANOVA, or an advanced statistic called multi-level, okay, multi-level analysis. Okay, so it's good to know how to change from the wide format to long format. Okay, plus code. Now we will create a new variable from the variable variable. Okay, so we will create a new new variable name family size. Okay, family size. Okay, and in doing so, we will have df age. Okay, and divided by 15. Okay, this one, okay, this one mean floor division. Okay, so when you get the result, you get the whole number, and also the remaining. We will ignore the remaining. Okay, so if you for example 75, we can estimate that from your age you will have a family size of 75 divided by 15, which is 6, right? Or 5. Okay, suppose for example 5. So we can like estimate about your family size. Okay, family size that you have 5 people in your family from the individual with a certain age. Okay, this is called floor division. Okay, for example, if we divide 30 by floor division, okay, 15, okay, we will get 2. If we have 38 and we for divide by 15, okay, we will have like 2 and some decimal, right? Some decimal. So but we don't use that. Okay, we don't use the decimal. Okay, we use the whole number. We don't use the remaining. Okay, that is why we call 4 division. So it will give the same um, the same result, which is 2. Okay, and okay, we're gonna show the result. Okay, example of family size. Enter the age and family size, age, and enter. Okay. So we create a new variable from the variable that we have, which is an age. So if you are an individual with certain age, okay, we can estimate the size of your family, okay, by 4 divide by 15, okay. You run, okay. So you see that this is the age and this is the new variable. Okay, so we divided 22 by 4 divide 15 and we get 1 and we ignore the remaining. Okay, it's work the same way for the rest. Okay, and this is how we create a um, new variable by do some calculation with the original or existing variable. Okay, what else? Okay, sometimes we need to record. Okay, record. Okay, it's on the same page 7, but right now we or at the line 16 to 18. Okay, so we're gonna count, we're gonna change code. Okay, so we have df, okay, and sec code, df sex, and we use map. Okay, map. Okay, and then we're gonna have a data structure called dictionary. Dictionary. When you read dictionary, you're gonna have a word and the meaning follow, right? So this one, okay, 0, okay, mean, oh no, a male, okay, 0, and female, 1, okay. So in the actual in the original data set, okay, we have sex and the value of it is male and female. So we would like to record, okay, the male to 0 and female to 1, okay. And the same if you have a liquid scale data, okay, sometimes you have the positive statement, so it's fine, okay, for the 1 to 5, but sometimes you have a negative, okay, negative statement, okay, so you need to record for the 5, you need to record to 1, for the 4 you need to record to 2, 3 the same, 4 to 2, something like that. Okay, so for the negative statement in the Likert scale. Okay, you need to recode. Okay, and this is the same way to do it with the Likert scale. Okay, so this I would like to introduce you this one. Okay, this one is the data structure called dictionary. Okay, you can see that you have a word name, the word male and female. Okay, and you have a meaning of 0 and 1 respectively. Okay, so you're gonna see what it's like. Okay, so print example of sex coding. Enter df sex code, and we have already dropped. Okay, already dropped the duplicate, so we don't need to add something else. So okay. Oop. So we're gonna print okay the text example of sex, and then we put enter, and then we show them we show the two variable. The one this is the original one, and the second one is the the variable that we have just created, the new one. Okay, by using recode function. Okay, so you see, if you male, sex code is 0. If you female, sex code is 1. Okay. Okay. Most of the the first session, okay, we do a lot about data screening, data cleaning, and data manipulation. Okay, so I think we need, in the reality, the researcher, this in the analysis process, the data preparation took so much time, maybe up to 40% of their analysis. Okay, to ensure that the data they ready for the further analysis. Okay, so we're gonna do these. Okay. Okay. Now, we're gonna make a visualization. Okay. First off, I want you to turn to page 9. Page 9. Okay. And we're gonna do on line 13 to 23. Okay, 13 to 23. Okay, we do it together. Okay, so mouse over. Okay, the button line and click plus code. Okay, now we're gonna, okay, I think we should name it df3. Okay, df3. Okay, and okay, in your handout is df, but I strongly suggest you to use different name, otherwise it will uh overwrite on the previous object. Okay, you should not, okay, is a advice, you should not use the same object name. Okay, and SNS is come from Seaborn, okay, and load data set, okay, and now we're gonna work with penguin, okay, and drop NA, okay, and drop NA mean whatever record or entry that have a missing value, we're gonna remove the whole row, okay, the whole row, okay, and this is in a technical term we call list-wide deletion, okay, and then we select, we use subset to select the variable, okay. You're gonna select bill length, flipper is like a wing for the normal bird, but for the penguin we call flipper. Length, okay, and last is species, okay, species, okay. So we create a new object called df3, and we use the data set that has already built in the package Seaborn. So when we're gonna use it, we're gonna use Seaborn dot load dataset, and we put the name of the dataset, and then we dot, okay, we're gonna drop any row with missing value, okay. And for the variable that we are interested in, we interest not all of them. We interested in the bill length, okay, with the unit of millimeter, the flipper, and the species, okay. So we're gonna create a histogram. The histogram is a visualization of how the distribution of your data, okay. So df, okay, df bill length millimeter, and hist here come from histogram, and bin here, you know, histogram actually made of a bar chart, okay. So this is the bin is the number of bar chart, okay, which I used 20 bars, and we need to give it a title, plt, okay, plt title, okay, we're gonna name it histogram of penguin bill length, okay, plt title. What's wrong with this? Oh, I forget to tell you that we need to import mat. Yes. Okay, give you some time. Okay, we need to import matplotlib dot pyplot as plt. Okay, so this module is used for create the visualization. Histogram box plot. Okay, we need this function. Okay. PLT X level. Okay. So bill length. Okay. And Y is a count or the frequency. Okay, for each length. Okay. And then we're gonna have a grid. A grid is like an area with the horizontal lines cut by the horizontal line, vertical line cut by it's like a frame. Okay, it will make our histogram look nice. Okay, and we need to show, okay, the histogram. So we have to end this script with plt.show. Okay, and we click run. Oops, we got an error message. Okay, something wrong here. View length. Okay, I need to check. View length th underscore mm. View length. Let me check. Penguin. Subset. Bill length. Flipper length mm and species. Oh, here is a DF3. Okay, it's a DF3. Okay, done. I need to zoom out. Okay, so you see that, can you say it is normally distributed? Might not be. Okay. Because actually it should be in a bell shape, right? It's a bell shape. But anyway, if you have maybe more or larger sample size, it usually have the normal curve distribution. Okay, and I would like to emphasize that the normal distribution is the assumption of many statistical analysis. So you need to make sure that you need to do a histogram for visually check whether your data is normally distributed. Okay. Anyway, suppose that I need to zoom in again. Okay. Bob plot. Okay, bob plot. SNS. Oops, need to comment. Bob plot. Okay, SNS box plot. Okay, and species. Okay, X equal species, Y equal flip length, and data here. Do not forget. Remember now we have the data object called df3. Okay, the reason, as I told you many times, that if you use the same, it will overwrite the previous one. Okay, so you lost the data. Okay, and PLT box plot of penguin flipper length by species. Okay, and please turn to the next page. Okay, it's on page 10. Okay, and line number 1 to 4. Okay, PLT X level species. Okay, and PLT X level flipper length, and the unit of measurement is millimeter. And we this is the grade. Okay, this is the grade. You see the vertical line and cut by horizontal line. So it helps us. Okay, if we don't have a grade. Okay, for this one, we don't have idea how much how many of the penguin have this bill length. Okay, so when we have a grade, it helps us read the value more accurately. Okay, so we're gonna run. Okay, we're gonna run. Oops, that's something wrong. Okay, don't freak out. Okay, we need to investigate. Okay, it show you what the problem is. Why? Ooh, okay. Right? Yeah. People length underscore or millimeter. Okay. Click again. Okay. This is the histogram. Okay. We've done already. And this is the this is the block plot. Okay. And it gives you slightly different information. Okay, so you see that we have 3 species of penguin. We have Adelie, we have chinstrap, and we have gentoo. Okay, and you can see that I imagine that gentoo will will be the biggest penguin, because they have very long flipper length. Okay, and the block plot is very common, especially when you do one-way ANOVA. Okay, the ANOVA, the idea is that you try to test the mean of the more than two population. Okay, more than two subpopulation, such like this case. If we would like to test statistically, we need to use the one-way ANOVA. But before that, before we do the analysis, we need to create the visualization. Okay, we use box plot. Okay. Now we're gonna start do the differential statistic. Okay, so this part it will be more fun. Okay, so I will zoom in and add code. Right now we are on page 10, and on the line 16. Okay, 16. Okay, we will have a DF4. Okay. In your handout is DF, but I changed to DF4. Otherwise, it will overwrite the previous DF but that we have done earlier. Okay, so DF4 S and S and load data set. Okay, tips. What's wrong? Oh, okay. So tips. Okay, tips here is it is 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 a part of American culture or Western culture that when we eat the food at the restaurant, okay, you have to pay, of course, but you have to give a tip to the waiter or the waitress. Okay, so this is the data about the day, the total bill, and the tip, that and the gender of the waiter of the service guy, whether male or female. It is we're gonna do the detailed analysis about the factor that influence the amount of tip, okay, later. Okay, but first of all, we need to check the data structure. Okay, we do the info. Okay, you see that there is 244 entry. Okay, we have a total bill. Okay, so for the whole price, when you have a dinner or lunch, and the tip that you give to the waiter or the waitress, the sex here is the sex um, of the waiter or waitress. Smoker. Okay, this is the area. Okay, for the smoking area, and this is the day. Okay, normally when people dining out, they would dine out in weekend, right? In weekend, like Saturday, Sunday. Yeah, we're gonna see whether the day in a week affect the amount of tip um, provided to the waiter or waitress, and the size here mean how many people in that meal. Okay, so we understand, and what is good is that you can see that the sex, smoker, day, and time, okay, already in a category, meaning that we don't need to uh, transform or change the level of measurement. Okay, now we understand the data structure. We know how many columns, we know the nature of the data. So we're gonna do the first inferential statistic, which is the easiest one. The easiest one. It's called one sample t-test. Okay. We're gonna check if the mean tip differ from $3. Okay, 3 here is $3. Okay, in the US or many Western countries, okay, it really depends. Okay, I remember once when I finished my lunch, they will give you a receipt, and they will have an option for you that you were gonna tip it by 10%, 20%, or 30%. Okay, so yeah, so it's a part of the culture, but we don't do that much. Okay, this is the quite a lot. But in Thai, maybe we give it depends on the restaurant, and you know, if the total bill is like 1,000, you may tip them 50 baht. I think it's okay, or 100, that's fine. Okay, like 10%. Okay, we're gonna create an object that contain the result. Okay, we're gonna name it one sample. Okay, result. Okay, one sample result, and we're gonna use stat. Okay, stat t-test one sam. Okay, stat here. Oh, I forgot to import the module for the inferential stat. Okay, just type form scipy. Okay, import stat. Okay, we don't need to import Seaborn again. We import earlier already. Okay, so yeah, it's already gone, the baby line. And the F4 tip. Okay, tip here is the variable. Okay, over here you see that they don't have s at the end. Okay, so tip, and whether it's equal to 3 or not. Okay, and we're gonna skip the line 20. It just give you an information. Okay, I changed my mind. We type, you know, because you know, in the reality, we need to communicate at least with ourselves. Okay, what the data is about. Okay, if we don't have any text like an explanation, we may get confused easily. So it's a good practice to have some information about the result. So we need to type one sample t-test result, and I will change this to okay, H1 or alternative hypothesis. Okay, so for for the one sample t-test, the null hypothesis is that there is no difference between the mean and the threshold. The threshold here, we specify at $3, right? So there is no difference between the mean and the 3. Okay. So let's see whether it will confirm or reject the H1. Okay. We print. Again, we have F string. Okay, F string contain the text and also the placeholder. Okay, we don't know exact the figure. We need to wait for the previous line before. Okay, and t is a t value. Okay, t value equal one sample result. Okay, dot statistic. Okay, and for for this one is a t value, right? So they can have the decimal, but we allow them to have just 4 position. Okay, 4 point. Okay, and we need to have the p. Okay, we have to have the p equal 1 sample result p value e. Let me check. F T okay. And enter. Okay. Okay. Anyone would like to volunteer to interpret this output? Anyone? What does it mean? Actually, when we in the social science, it's really depend on the field you are. Okay, if you come from and doing research about living things, okay, the p-value is set. It should be lower than um 0.01. But if you work in a social science field, okay, you are allowed to have a p-value lower than 0.05. Okay, but what about here? How much is it? Okay, so remember we allow them to have like E here uh, is a way to write the 10 power minus number in a scientific way. Okay, so this one is good is it mean 10 power minus 1 or 1/10. Okay, so 1/10 is 0.9. which is higher than the 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 value that we have set, which is the 0.05, right? So what should we do? We should confirm the null hypothesis. So there is no difference between the mean of tip, okay, and the threshold, which is $3. Okay, we can check. Okay, we can check. Print DF for tip. Okay, you see that this is the actual mean. Okay, for this data set is a 2.99. 2.99. Okay, so it's very close to 3. So that is why when you taste it, okay, your taste is interpret that, okay, this figure and this figure is not different scientific, not different significantly. This number and this number are not different statistically significantly. Okay, but what if I change it to 4? Okay, and you run. Okay, you see here, and you see here, this is the t value. Actually, if we do it by hand, then we have a formula, right, for the one sample t-test, and then you will have a df. You will have a df, and you're going to use the df to open the table. Okay, the t table. Okay, and you have to look at for the degree of confidence. Okay, if it two tail, okay, like in this case, okay, and you have to divide it by 2, which is 0.025, and then you look at the number, and we call that t from the table, and you compare t, and this is the t from calculation and the t from the table. If the t from the table is lower, okay, is lower than the t that we calculate by hand, okay, we're going to reject because it's fallen the critical area. But if they're higher, okay, if they're higher, okay, we cannot reject. We have to we have to accept the null hypothesis. Okay, but for this case, but any software for statistical analysis, you don't need to worry about you know, the critical area, the table. You just look at the p and check whether your p is lower or higher than your criteria, which is 0.05 or 0.01. Okay, what about this one? What about this one? This one equal to 10 power minus 24. So it's very small. You know, it's very small. It is like 0. 0, 0, 0, 0, 0, 0, 0 up to 23 and 4, 2, 1. So it's lower than the cutoff point, which is 0.01, right? 0.01. So this round, okay, this round we reject null hypothesis and we accept the alternative hypothesis. So what does it mean? How to interpret? We're going to interpret that this number and this number is different significantly. Okay, significantly is different significantly. Okay. Okay, so we're gonna move to the second type of t-test, which is called independent t-test. Okay, when I use the term independent, okay, it means that we have two different groups. Okay, so I'm gonna comment out all the print and I will give a comment that we're gonna do independent t-test is on 23, the line 23 on page 10. Okay, on page 10. So we will create an object called male tip, okay, from df4, right? df4 sex, okay, equal male tip, okay, equal. Okay, so for this one, mean there is two sides of the equal sign. Okay, this is an object that contain the information from the right side of the equal sign. For the equal sign, okay, we select the column sex, okay, and it should be male, okay, and we use the information on the tip variable only, okay, and the female the same, follow the same way. We change this to female, and we change this to female. Okay, and then we're gonna analyze the data. Okay, so we have if you want to know, if you want to see, I can print it out for you. Male tip head, okay. Ooh, what's wrong? Let me check. Okay. Okay. If you want to access the variable, actually we use one square bracket. But if you want to access into the value of that variable, you need a double um, square bracket. Okay, like this one. Okay, I still got an error. Let me check. Double mail. Okay, tips. Okay, so let's see. Just a minor, but it's a serious mistake. Even you miss you put in the wrong place in your syntax, but it could end with big mistake. For the like this one, I get an error, but I want you to have a positive attitude toward the error message, because you can learn a lot. Okay, when you can debug it. Okay, so it will build up your skill. So learn from the mistake is the way to excel in any area of your interest. Okay. Okay. So okay, this is a male. It's a male. This is a female. This is a female. Okay, so we're gonna compare. We're gonna um find the mean of this. Okay, the mean of the male and the mean of the tip given to the female or the waitress, and we compare whether it's different. Okay, whether they are different significantly. Okay, and I will cancel this out, not cancel, comment out. So the computer will skip, okay, to this line. Independent result stat t test underscore ind. Ind here mean independent, okay, and male tips and female tips. Okay, and we need to add an argument. Okay, because I forgot to tell you that you need to check the assumption of any statistic. Okay, the the common one is that your data has to normally distributed, and for the t-tests we need to ensure that the variance of the sub population equal. If you don't know the variance, you should put equal equal wall, false. Okay, equal wall, false. Okay, because you don't know the variance of the population, okay, of the population, of the subpopulations of male and female. Okay, remember this is just an sample, not the population. Okay, this is the X bar actually. Okay, and we need to print. We need to print for communication. In independent t-test male versus female. Print the actual result. Again, we're gonna use the F string. Okay, the F string. So we have T equal, okay, this is a placeholder because we don't know the exact number. Okay, we need to calculate from this line, okay, and put whatever result in here. Okay, so independent result statistic, and we allow them to have like 4 decimal. Okay, for F stand for float, and P equal independent result P value, and we allow them to have like 4 digit, then enter. Okay, guess. Okay, we like to make a prediction. Do you think that male and female they were tipped equally? Do you think that the gender could affect how much they were given? Anyone would like to make a guess? No one. Okay. Okay, you may have the prediction or hypothesis in your mind, but anyway, we're gonna see it. Okay, what does it mean? Anyone? Remember, if you don't calculate by hand, you use software, whatever software, the SPSS, SAS, or Python, or R. Okay, it's very easy. You just look at the p-value. Okay, you just look at the p-value and compare with your cutoff criteria. In this, and in a social science, it should lower than 0.05. In the health science, maybe in a medicine or in the pharmacy, it has to be lower than 0.01. Okay, but for this one, is equal to this one is mean 10 power minus 1, or 1 over 10. So it means it's just it's just 0.137. which is higher than the cutoff of 0.05. So we're going to conclude that male and female treat equally. They will be given tips in a very equal amount. Okay, there is no gender bias here. Okay, and the last one, we're gonna change. The last one, we can the last type. Okay, is a type number 3 of t-test. We call pair t-test. Sometimes you have the situation that you repeat, okay, at the start, and you give the intervention, okay, and or treatment, and then you collect the data again, and you try to compare pre and post, something like that. So this kind of test quite popular in social science and also in the science. Okay, so but we're gonna do something more fun. Okay, you can see that we often use the data set that built in, okay, built in a particular module like Seaborn. But this round, okay, I teach you how to import, okay, your own data, okay, your own data and what you're gonna do, okay. But anyway, we type pair t test, okay, and we will change to fictional student. Okay, don't look at your handout. Okay, we're gonna use the totally different. Okay, um we're gonna use our own data, not data set built in any module. Okay, so I will send you a file. Okay, a file. So oops. Let me check. Fictional. Okay. Okay. Anyone get the data set? Okay, it's an Excel file. Okay, it's an Excel file. Okay, and please save in your local computer. Okay, anywhere in your computer, but you have to remember exactly where you put it in. Okay, and now we're gonna we're gonna show you what is it like. I need to stop share and show you the data, because we're going to use the same data for ANOVA. Okay. Okay. I will. Okay. You see that? This is the frictional data, meaning that it's not the real data, but anyway, it's just the data that are not in the module or the package. Okay. So when you prepare your data, you collect the data, usually you put it in an Excel like this. Okay. And yeah, you have an ID, you have a whatever variable that you are interested in, but this is come from the educational research. Okay, so we have gender of the student, we have test score before the intervention. Okay, and we have the test score after the intervention. Okay, and we're gonna um, uh, conduct the pair t-test to examine whether the after is different from the before. Okay, and I would like to introduce you another 3 variable that we're going to use very soon in the afternoon session. We're going to talk about one-way ANOVA. Okay, so we look at I need to enlarge it. Oops. So we have post-test score. Okay, it's taught by 3 different method, teaching method, um, uh, teaching method A, teaching method B, and teaching method C. If we want uh, to examine whether the mean among these 3 groups are significantly different, okay, we're going to use one-way ANOVA. Okay, and we're going to use this, okay, data set. Okay, and I'm going to teach you how, okay, how to upload, okay, upload your file to Google Colab. Okay, I'm gonna share you again. Okay, so you see in your left, the most left, you're gonna see kind of file folder. Okay, you click on it, you see, you click on it, and then you see the upload sign. Okay, you click, okay, you click, and then you upload, okay, the Excel file that I had sent to you. Okay, and you see the file is already in your Google Colab environment already. Okay, so the name is frictional student data. Okay, I think that you can close it. Okay, um, we need to stop at this point, because if I continue with the pair t-test, it will take some time. So have a lunch, have a nice lunch and yummy lunch, and come back with fresh, fresh fresh brain, and we're gonna move on to the next analysis, more complex. Okay, so see you at 1 p.m. Okay, 1 p.m. sharp. Okay, thank you. Okay, everyone is ready for the afternoon session. I hope you guys feel better because of the lunchtime. I hope everyone have a yummy meal and enjoy and take a small rest. Okay, and maybe ready for the challenging part in the afternoon. Okay, um, we in at pair t-test, right? Pair t-test. Um, the idea is that you repeatedly measure the variable 2 times. One at the beginning, at and you give the participant or your subject, an intervention or treatment, and then you um, collect the data after that, and you're about to compare um, the pre and the post. Okay, um, remember that this time we're gonna use the data set from the external file. Okay, and that file is already uploaded. Okay, um, the name is frictional student data. Okay, it's an Excel file because it ends with XLSX. Okay, um, first off, we need to um, we need to we need to create an object. This time, I name it df5 and equal to read um, underscore Excel. Remember at the beginning, we import a module called OpenPy Excel, and that module have ability to import and read the external file. Okay, and so we type read underscore Excel, and we have to be very careful and be accurate. Okay, because we have to type, okay, the name um, exactly as is. Okay, so the file start with the big F. Okay, frictional underscore student underscore data and XLSX. Okay, and we're gonna run okay, and we see nothing, okay. We see nothing because um, we didn't print or show the data set. As I told you as I tell you very often that once you have a data set, you need to explore, or we do something called data screening first, right? So we're gonna see the data um, structure using um, info method, okay? And we click run. Okay, so you see that we have an ID, we have gender, we have test score before after, and we have three types of post-test score by different teaching method. And we have a rubric score. But for this time, we're gonna compare, okay, whether the before and after, okay, score are different significantly, right? So, okay, I comment the info part, okay, because we know the data, the information quite well already. And we're gonna check, okay, whether this data set contain any missing value, okay. So we print, okay, we print data 5 dot is now, okay, and sum. So what does it mean here? Print mean we display, okay, we display the information, okay, we display is now, display missing value, and we sum, meaning that we count, okay. So it will give you an idea about how many missing values appear in this data set, okay, and you click run. And you can see that there is no missing value, which is a very good thing. But if there is, you need to impute by mean or median, okay? Then we're gonna do the analysis, okay? So I I create create um an object, okay, name pair result to store the result of the test equal to stats t test, okay, t test real real rel mean relate, so the before and after they somehow relate because it collect by the same subject, okay, we collect the same person just before and after the treatment, okay. D5, okay, and you have to write the name of the variable accurately, okay. If you could not remember, you can see here, okay. So test uh, underscore score and before, okay. And sometimes it's guide, you read the suggested syntax. If you think it's correct, you just put the tab, okay. So it save your time a little bit, okay. And then we need to print, okay, we need to print the information, okay. So we need to print the text, say pair t test before BS versus after, and then we may need to add enter. Okay, and then we print. Okay, again F string. Why it has to be F string? Because what in the string, what in the quotation mark uh, is the text. So it must be surrounded by the quotation mark, and it also contain the placeholder. Okay, we don't know exact number, so we need it, the number to be processed in the preceding line. Okay, once it's done, it will show in the placeholder. Okay, so we type t equal to, okay, this is a placeholder, pair result. Okay, pair result and statistic, and then we allow the t value to have for the decimal for 4 digit. Okay, and then we have a p value. Okay, and this, for this one, p pair result dot p value, and we allow them to have the decimal 4 point. Okay, and we will write the 10 power minus. Okay, this is the way to write it short in scientific way. Okay, rather than print out like 0.0000 for 40 times, you just type 10 power minus 40. Okay, it's a shorter way. Okay, and then um you should be ready for um for the result to be displayed. You click run. Okay. Ooh. Mm-mm. What happened? Okay. Um, so we are seeing the result, or we have a t value, okay, and we have a p value here, and I think it should be this one. Okay, I put it wrongly, sorry. So it should be a comma, and then the p equal, run again. Okay, so you see that uh again, it's very easy for any um statistical software. You just look at your p value and compare it with the alpha, right? Alpha. The alpha here we set at for the social science field at 0.05, and for the health science, we set at it should be below than 0.01. Okay, for this one, okay, how much is it? The p-value is higher or lower than the alpha. So for this one, the p-value equal to 0.000023418. So it means that 2.3418 multiplied by 10 power minus 4. Okay, so it's smaller, is less, much less than the alpha at 0.01. So we're gonna say that the before and after, they differ significantly. Okay, but you may have question in your mind. Okay, because the null hypothesis is just compare the differences. Okay, but it doesn't give you an information about which is higher, before or after is higher than the other. So I would suggest that you will should do the print and df for the f5, okay, and taste score before, and you find the mean, and then you do the same. You do the same. Okay. For the test after. Okay. The test after. So what does it mean here? What does it mean here? It means that you take the data from the column test score before, and then you find the mean, and for another column test score after, which is the data that we collect after the treatment. Okay, we find the mean. Okay, so we run, and you see this. Okay, this is the pretest 67.7, and for the post test is 73.7. So you can see the difference. Okay, that is why when you test it with the PATI test, it show you that it different significantly. Okay, at the level of confidence at 99%. Okay. Okay, we're gonna move to ANOVA. Okay, we're gonna move to ANOVA, and we're gonna do something a little bit more fun. Now we are at page let me see, page 11. Okay, and we have to import many many module, okay, in order to do the job, but some of them have already imported. Okay, so we will do import the rest. Okay, so I zoom in. Okay, we're gonna import, okay, from line 24, import stat model, okay, dot API. as SM and import, no, from stat module, okay, you formula, okay, dot API, you import OLS, and from stat model, okay, you import multi-com and pairwise Tugi HD. Okay. I want to just briefly tell you about the idea behind ANOVA. Okay, suppose that in our population, okay, we have more than two subpopulation. So when we calculate, we took a sample and we calculate the X bar. So the X bar from the sample one and X bar from the sample two and X bar from the sample three. And we would like to, if you have just two group, you can do the independent t-test. But if you have more than two, in this case three, or more than that, four, five, you need to do an ANOVA. And the null hypothesis for the ANOVA is that there must be for the null hypothesis that all across sub population, okay, subpopulation 1, subpopulation 2, and subpopulation 3, all of the mean are the same. But for the null hypothesis, but for the alternative analysis, okay, it says like there is at least pair of the mean, okay, uh, differ, differ, okay. If we can test that, okay, there is at least one pair, okay, one pair of subpopulation that has a mean different significantly, we have to do a little more step, okay, which is we call ad hoc pairwise. And there are many techniques, but the idea is that we need to know which one, okay, differ, which one the same, okay, because the alternative hypothesis, it say there is at least, so it can be possible that there are more than one, okay, maybe a population 2 different from population 1, and population 1 different from population the subpopulation 3 is possible, okay. And I'm gonna change, okay, I'm gonna change the data set, okay. And the data set we're going to use right now, we are at on page 12, okay. But we're gonna not use the data set tips, okay. We will use others, okay. DF, I think it's 6, right? It's 6. And this data set is stored by in Seaborn, okay. And the data set name Iris, okay. The name data set name Iris, okay. And we need to know the data structure or the data information, or somebody would call metadata, okay. So we use info and we run. Okay. So you see that there is a 150 entries. Okay, and we have 5 variable. Okay, sepal. Okay, is a part of flower. Okay, sepal length, sepal width, petal length, and petal width, and the species. Okay, and the species. Okay. Anyone have ever seen iris? Iris is a name of a flower. Okay, so I'm gonna show you what it's like. Can you see? Oh, what's wrong? Oop, 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 oop. Okay. Okay. Everyone can see the photo of iris, right? Oop. What happened? Oh, okay. Okay. Um, you can see the photo, right? If you cannot, just let me know. I'm not sure whether the screen share the photo of iris and you can see it or not. Oh, what happened? Okay, so you see that there are 3 species. Okay, if you are a biology person, you will know that. Okay, this is a species name. Okay, it consists of the genus. Okay, Iris, and this is the species specific. Okay, this is the Iris setosa, Iris versicolor, and Iris virginica, and you can see there are 2 component, there are 2 part. Okay, the bigger one here, the bigger one here, uh, the bigger one here is a sepal, is a sepal. Okay, and I think I should change to the new one. Okay, this one. Um, ah, okay. Okay, so um, this part, okay, this part is called sepal. I'm sorry, petal, petal. And for this one, the bigger one is the sepal, sepal. Okay. Um, The botanist or the scientist that study plant, he collect data from the iris flower, and he kind of measure, okay, you see this is the petal part, okay, this is the length and this is the width, okay. This is a sepal part, the same, they measure the length and they measure the width, and this is what the data frame or the table like. They have five column, okay. They have the sepal length, sepal width, petal length, petal width, and the name of species, and for each there are 50, okay, of them, okay. So set aside for 50, okay, and for versicolor another 50, and the versicolor another 50. So combine all, we have 150, okay. Let's go back to our Google collab, okay. I hope you can see now we are on the Google Colab environment. Okay, so I comment out because I know the data structure, I know the information about this data set already. And let me check. Okay. We're gonna do the one way ANOVA. Okay, one way ANOVA. Um, at first, we need to have group. Okay, a group. So um, we create an object. Okay, name group iris. Okay, and equal to group. Okay, I can send this script to you via the chat because it's quite long. But anyway, you may look at here and work on your collab. And if you cannot follow me, I can share the script to you via the chat box, okay. And petal length, okay. And oop, okay. I need to check. There is something might be wrong. Group iris equal group for values for name and group in DF6 group by species observed equal false. Let me check There must be something wrong. Function. I think I need to import. Not sure whether. Okay, we import scipy. We do it again. Import. No. From scipy import stat. Okay, and import stat models dot API as SM, correct? And from stat models, stat model point formula dot API import OLS. And lastly, from stat model dot stat multi-com import pairwise 2G SH HSD. Let me check again. For the group iris, group, no function. Petal length for name group in group by species and observe. Okay. This is only one group petal length. It should work fine now. Okay. So we create group. Okay, remember that we have we have three species, right? Iris setosa, Iris versicolor, and Iris virginica, right? So we need to create a group for those, and we have to select, okay, the variable that we would like to compare among three species, which is petal length. Okay, so this is the how we create the group variable. Okay, it's quite long, and I gonna send it to you shortly, and we should be ready for the analysis. So ANOVA result, okay, and I will say iris equal stat stat f one way. So it is a f test. It is a f test. We put the asterisk, the star, okay, and group iris, and we're gonna print. Okay, we're gonna print um gonna print enter one way ANOVA. it should be all capital letter. Result. Okay. Iris. Okay, and then we should put the result. Okay, we need to have again F string. Inside the quotation will be the text. Okay, and the placeholder, the F. Okay, this is the stat. Okay, and placeholder and ANOVA. Okay, so ANOVA result iris, which is here, dot statistic, okay, and colon 0.4f, meaning that for the f value, I allow them to have 4 decimal, okay, 4 point of decimal. And for the p-value, okay, I put the ANOVA result iris dot p-value, and again for 4 point decimal with the 10 power minus some number, okay, to show how small it is. But it's a way to write the number in a scientific way, which is very short and concise. Okay, everything should be fine now. Okay, so what does it mean here? We have a f value, okay, but as I told you very often, that for the statistical software, whatever it is, it's easy. We just look at the p-value and compare it with our alpha that we prefer. For this one, it means p-value equal to 2.8568 multiplied by 10 power minus 61. So it means that it's very, very small. Okay, it's like 0.000 up to 90 0 and 28568. That is the value, the actual value, very small, very much smaller than our alpha, which we set. Okay, because this is a scientific uh, study, scientific research. So we set our alpha should be lower than 0.01. Okay, 0.01. So this is significant, right? If it's significant, okay, we need to investigate. Okay, so which pair are different? Okay, it should be versicolor different from uh, setosa, or versicolor different from setosa, or setosa different from virginica, something like that. So there are 3 possible pairs. So we need to investigate which one are different. Okay, but anyway, I think we need to have a table. Okay, a table. So you cannot just report this in your research report. You need something called ANOVA table. Okay, in order to do that, I think I will copy. I will copy and share this to you because it's quite long. It's already in the chat already. Okay. Okay. What we gonna do next? What we gonna do next? Okay. We will create one way ANOVA table. Okay. One way ANOVA table. And we need to have a new object that we store, okay, the information about our table. Okay, iris equal to OLS, and our variable that we interested is petal, right? Petal length. Okay, petal length, and we need to have the curvy sign, the wavy sign. Is on your top left on your keyboard. Okay, is look like this. It's the same button that you change the language. Okay. I suggest you to hold it. Okay, shift and hold it for some time. Okay, it's gonna change to this side. This side is called tilde. Okay, just um push push and hold for some time. It's gonna change to tilde rather than change the language. Okay, and species, and we need to specify the data, the F6, and fit. And now this is a table. Okay, equal to SM stats and Nova LM. And we put the model in type 2. Okay, and I'm gonna show you we print it. Okay, so I'm gonna show you for 5 seconds in order to make sure that you can type and follow me. Um, oop. So in the first line, you create a model, ANOVA model, okay, and you use the function OLS, okay, and you put your model, okay, in the quotation mark. So you would like to compare the petal length across 3 species, right? So the model will look like this. So petal length on your left and followed by the tilde sign and species. Okay, and the data is the F6, and we fit the model with the data. And then we create what we call um, ANOVA table. Okay, ANOVA table. Okay, I should change this to table. Sorry. ANOVA table. Okay, iris. Okay, and sm dot stats dot ANOVA underscore ln, and you put the name of your model and the type set at 2, and then you print it. Okay. Okay. Let me check. There must be something missing. Let me check. Let me check. This one. This might have to be table. To be consistent with this, okay, we use table, okay, and we run. Okay, so right now we have this, and this is called a one-way ANOVA table, okay, and you can see that we have between group variance and within group variance, okay, and we have some square of each, okay, and then we have df, okay, and we have um, this one, this one, this one, exactly the same here. This is a p-value, and this is the f value, exactly the same, okay. So you need to have this in your report, okay, not only this, okay. So what does it mean? It means for the p-value here, you see that it significant, meaning that you have to um, reject your null hypothesis that all three uh, groups or three species have equal petal length, and you have to accept your alternative hypothesis that at least one pair of species have the petal length different, the mean of the petal length different, okay. So what we're gonna do is we will investigate. No, before we do that, we need to do a visualization, okay. Remember, I talked in the morning that we need for the box plot, it is the visualization we must do, especially when we have more than two subpopulation, okay, or subgroup. We're gonna do the box plot first, okay, box plot. Ah, SNS box plot, and we have X, okay, which is a species, and we have Y, okay. On the y-axis, we have petal length, and we have the data is from the F6, and we have to name our box plot, okay. So PLT title, okay, title. So we should name it box plot, box plot of petal length, petal length by species, and PLT X level, okay. This is the name of the X-axis, Okay, so this one is species. Oops. Because it's a text, it should be surrounded by quotation. And PLTY level, which is petal length in centimeter, okay? Not millimeter, okay? And we need to have a grid, okay? It helps us read the actual value, okay? So grid is important. We said it's true, and we show it off. Okay, everything should be fine. I'm gonna click. Okay. Okay, this is the short version of the result, and this is the ANOVA table. Okay, and this one you should put on your report as well as the visualization. Okay, this is the box plot. I will zoom out so you can see. Okay, you can see, you know, with visual inspection, we would say we don't need, you can make a very educated guess that the mean of the petal across the three species are all different, right? You can see the middle line run across the blue box is the median, okay? You can see that they spread widely, okay? But anyway, it's just the human observation we need to test in a rigorous way. So we're gonna do something a little bit more and fun. Okay, we call ad hoc. Okay, ad hoc analysis. Okay, we will compare. Okay, one pair at a time. Okay, and three pair possible, right? So we're gonna know which are different from each other. Okay, so for this one, we will use the if. Okay, these are like the computer thing. Okay, we set the condition. Okay, if the ANOVA result iris p-value, okay, is less than 0.05, we will do the Tukey test. This is the name, only the name, and that contain the result of the Tukey analysis. Okay, and we have pairwise. You can see that it suggests us, okay, because they are an AI base, so they can they're very clever. If you see, okay, it is the right syntax, feel free to click hit the uh, tab button. Okay, it saves your time. Okay, and print 2G, 2G HSD post hoc. Anyone here can give me a reason why we call this post hoc? Test? Because we will do it only if we 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 have the f value that is significant. Okay, but if it not significant, meaning that all three group or three species in this case have the petal length, the mean of petal length the same. We don't need to do the Tukey HSD. So is this like a condition? We will do it only if um, the the f value is significantly different, statistical significantly. Okay, so that's why we call it post hoc. We don't need to do it all the time. We do it only if it's significant. Okay, and print Tukey summary. Okay, remember this is a computer science thing. Okay, after if you have to end with the colon, and when you enter it will indent, meaning that that section is a part of if. Okay, else the same. Okay, you have to end with the colon, and when you enter, click enter. Okay, hit enter. Okay, you you can see that the text is automatically indented. Okay, so we print Tukey HSD skip. Okay, because f value is not 6. Okay, should be all right. Okay, so we did the box plot already. So we have this box plot, and we have to copy and paste them in our report. And we can do something called visual inspection. Okay, just your own observation, and you describe that. Okay, you can see that the boundary of each box are set apart. Okay, there is no overlap among these three boxes. Okay, they just describe the visualization. Okay, but if you want to test it, okay, in a rigorous way, you do the Tukey, okay, HSD. Okay, so I gonna click run. Okay, so successfully executed, and we have this one. Okay, so we have setosa compare with the versicolor in terms of their petal length. This is they're different. Okay, is here. Let me see, setosa and versicolor. Setosa is here, versicolor is here. This is setosa over here, and this is the versicolor. Okay, if you this gap equal to 2.7 centimeter. Okay, and for the setosa and versicolor even higher. Okay, so this one setosa and virginica over here. Okay, so it is 4% something apart, and versicolor and virginica, which is these two. Okay, they just apart by 1.2 centimeter. Okay, and I would like you to look in particular in the column called P A D J. This is the p value. Okay, meaning that these two are different significantly, and this one also significantly, and these two, okay, and this these two, versicolor and virginica, are different significantly. So all pairs possible that could happen, they different significantly. Okay, so once again, for one way ANOVA, at first you get this, you get the F value, you get the P value, and you can see that is much less than the alpha, which we set at 0.01, right? Meaning that at least one pair, they're different. Okay, at least it could be more. Okay, so in this one, we need to do the post hoc analysis to test if these two different. What about these two? And what about this little short guy and this tall guy are different? Okay, so this is the end of ANOVA. If you have any questions, just let me know. Okay, we're gonna do ANCOVA. ANCOVA. Okay, let me see. It's on the page on page 14. Okay, it's on page 14, your handout. Okay, and you can see that the ANCOVA is on the line number 14. Okay, and you can see that 15, 16, 17, 18 we have already done, right? We have already import seaborn pandas stat model API, right? Let me check again. Yeah, stat API SSM, and also the stat models formula API as OLS. We have already done all. Okay, so we should good to go. Okay, with the analysis. Okay, we need a new block of code. Okay, again, just mouse over the border of the latest box. Okay, and click plus code. Okay, and on the line 21 df, this time it should be 7. Okay, 7, and equal to the we need to tell ourselves and others that okay, this is the ANCOVA. Okay, anyone got the concept of ANCOVA, right? ANCOVA, let me explain the concept to you. Um, if you have um, if you have independent variable and dependent variable, right? okay, and you would like to investigate whether the independent has an effect on the dependent variable, okay? But however, in the real world, there are other variables that that subject interact with that could partially affect the dependent variable. Okay, if we not control it, we will call that variable as the extraneous variable. Okay, extraneous variable, which is very dangerous. Okay, we cannot be 100 sure that the change that we see in the dependent variable is only come from our independent variable, but is this a mixed effect between independent variable and that extraneous variable? So in statistic, okay, there is the way to control the extraneous variable by including them in the model, okay, and we change the name from extraneous variable to covariate. Okay, okay. In independent, okay, and we think that it affect dependent, right? But in reality, we have independent variable and extraneous variable. Okay. Um, let me check the Thai name for the extraneous variable. I'm quite sure. Yeah, it's the ตัวแปรแทรกซ้อน in time. Sorry for the international participant, because we have many terms in in our analysis. Yeah, so right. So in this case, so is the change or the impact of anything on this is the mixture between the thing that we think and the thing that we need to control. In order to control, and I would say statistically, we use and cover by putting, we create a model, okay, and we change extraneous as covariate. It's a part of the model, and we can control it. Okay, hold it as a constant, so we can see the difference. Okay, you can see the difference of purely the dependent variable. Okay, once we control the extraneous, or in this ANOVA context, we call it covariate. Okay, so I hope you understand the concept. Now we're gonna uh, create a data set. Okay, it's df equal df7 equal df, and we drop na. Okay, of three, okay, of three variable. We need to select first, select tip, day, total bill. Okay. Okay. It should be okay. That's it. Okay. Let me explain to you this line. Okay, we create a new a new object name df7. Okay. I told you already that if we would have changed it, okay, it will overwrite on the previous one. So that is why I have so many version of df, and this is the original one. Okay, this is the original one, and we select, okay, the variable tip, day, and total bill. Remember the dependent variable here is a tip, and independent variable here is a day, is a day. So meaning that if I die out on weekday compare with the weekend, okay, does the day matter in terms of how much I'm gonna pay for the tip? I would give for the tip, meaning that, okay, if I go on Monday, have lunch or have dinner on Monday, I give less. But if I go on weekend, which can be Saturday or Sunday, I give tip, more tip to the waiter or waitress. Okay, but our ex, extraneous variable is a total bill. Okay, it means that, okay, if I go on weekend, if I go on weekend, which is Saturday and Sunday, and my total bill very high, suppose mm, 2000, and that 2000, okay, has an effect on the tip or not, in addition to the day. So I need to control. I need to control the total bill. I need to control the total bill by set the total bill as a constant. So I can decompose. We call decompose the effect. Okay, that the change in the tip is due to the change in the dependent variable. Okay, and we use, I hope you understand the role of these three variable. Okay, this guy is the dependent variable, and this one is the independent variable, and this one is the covariate in the context of ANCOVA. And okay, we're gonna make a model. Anyone understand this, right? Drop NA, meaning that any record or entry that has a missing value, I will delete that row. Okay. Um, to ensure that our data is clean and ready to go for the next step. So I gonna model model the encoder, okay, using OLS function, okay, and the model has to be surrounded by a quotation mark, so it's a tip and a tilde, okay. For you, the tilde is I use Mac notebook, so um, I use different bottom to change the language. But if you use a window, okay, this tilde is the same button for you to change the language. So my advice to you is to hold the shift and hold the tilde sign. So it will eventually change to tilde at the end. Okay, and big C here mean category, right? Day is Monday, Tuesday, Wednesday. Okay, they are category. They are like nominal scale. So we need to clarify the type of data for each variable. Okay, for the day, it is just a name, right? Monday, Tuesday, Wednesday. So we add C, which means category. And we include total bill as a covariate. And the data, we use the DF7, okay, DF7 and dot fit, okay, and we need to create ANOVA table, okay, ANOVA table. Let me put the comment here. Show ANOVA, ANCOVA, I'm sorry, ANCOVA table, okay. So the table, this is the object contain the table. Okay, so SM stat. And this one, we're going to use function from ANOVA. Oop. This one, ooh, this one, wait. This one, after SM stat is ANOVA, not ANCOVA. So we're going to use the style of ANOVA, okay? And LM mean linear model, okay? And the model that we specify is the model underscore ANCOVA, okay? And there are many style. The type is the style, okay? So we print ANCOVA table, which is tip day plus total bill, and print and cover table. Okay. There is an error message. Okay. Don't worry. We're gonna debug it. Okay. Let me see. Let me see. Select. Select. Oh, it's subset. Yeah. When you would like to select, we use subset. Okay, we use subset. Okay, select the variable. We don't use select, but subset here means select. Okay. Okay, let's do it again. Okay, error again. Tip day total bill. Let me job NA subset tip day total bill job tip something wrong here. So let me check. Check the name of the column. Mm-mm. Ah, okay. So the F here is the data set from um, the data set from different one. Is a remember the survive and age, the embark. This is the data set from Titanic. Okay, so we need to do this. Seaborn data set download data set uh, tips data set tips, and then okay, let's see. Okay, it's done. um the problem that I faced a second ago is that the DF originally the title, the Titanic data set, but this data set that I want to work on is the tips. So I need to download. I need to download the tips data set. Okay, so the way I download it, okay, I just put the module, which is Seaborn, and load data set, and I put the name of the data set surrounded by the quotation mark and put it in object df7, and then I drop any row with the missing value, and I select only three. Okay, only three: tips, day, total bill. Okay, and I create the model for the encoder. Okay, I show them that okay, the tips, okay, is affected by day and total bill. Remember, the day here is the independent variable, and the total bill here is the covariate or the extraneous variable, okay, that we need to control it. And once we got the model, we fit it to the data, and then we create a table in we use the style of ANOVA, okay, and we print, okay, information here, and we print it out. Okay, so you see that, this F, I think the whole table, you have to put it on your report, okay, but what difficult is you have to interpret the output, okay. So let's get started with our our independent variable, okay. You see that, this is the um, p-value, okay, in the ANOVA and ANCOVA context, PR and greater sign F mean p-value, okay. So you can see here, what is the actual value is 8 point something multiplied by 10 power minus 1. So it just 0.8019 something, right? So point 8 is higher than our alpha, right? Our alpha is because this is a social science, the alpha is set at less than 0.05. So this one is higher. So we can say that the day doesn't matter. Meaning that if you go on Monday or you go on Tuesday, okay, the day does not have an effect on the amount of tip you pay for the waiter or waitress. I like this one. Okay, I like this one. Okay, this one is a covariate, right? And you can see the p-value here. You see the p-value here, and you see that is another way to write it is 1.22 something multiplied by 10 power 32, which is very, very small, okay, much smaller than 0.01, so it's significant, okay. So meaning that we can interpret this on the condition that we have already exclude the effect of this, okay. We already decompose the effect, okay. For this one, we include in our model, and when we interpret our independent variable, okay, we decompose or we make the total bill as a constant, okay. So you can see the real effect of the day on the bill, okay. And you can see the strength of the covariate in this case. So of course, if you is common is it fit in our common sense. If I have a very big bill like 3,000, I supposed to give the waiter or waitress 10%. I'll give them 300. But if you have like 2,000, I give them 200. For the total bill up to 5,000, I supposed to give them 10%, like 500. Okay, so this is a very strong. Okay, this is very strong, but good our focus is on the day, and we include this in our model, and we control with we treat it as if it is a constant. Okay, I hope you understand, and I'm sorry I'm late for the afternoon break. Okay, I will end up the ANCOVA at this point. Um, and we're gonna take 10-minute break. So please come back at 2:30. Oh no, 2:45. Okay, 2:45 p.m. Thank you,ครับ. Um, Before we do the coding, I would like to just briefly review um, about the concept of correlation and regression, okay, which is the last topic for today. And I think clarify first and do the code, you will understand better. Um, okay, can you see the slide? It's a Canva. Can you see it? Yes. Okay. Okay, good. Um, okay. When we talk about correlation, okay, we talk about um, the relationship between two variable or more, and and this is the positive correlation. Okay, so this is the x and this is the y value, and you can see that when we increase the x, the y also increase, right? And we will have um, the line like this. So we call this as have these two variable have a positive correlation. Okay, so the max for the correlation coefficient is +1, and the least, okay, correlation coefficient is -1, and it's a negative, like the graph in the middle. Okay, you can see that if the y, we increase the x, the y um, decrease, so it go in the opposite direction. Okay, but anyway, we can say that it had a strong relationship between the two, even they go in the different direction. Okay, um, unlike the one on the right, you can see that we cannot see the relationship between the two. So there is no pattern here. So for the correlation coefficient for the right graph, um, we call it scatter plot. Okay, is close to 0. Okay, so if there is a rule which you need to cite the reference, like if the correlation is 0.1 to 0.3, we have like a very low correlation. Okay, either positive or negative. If you have like 0.4 to 0.6, we have a medium uh, uh, correlation. Okay, medium level of correlation. But if you have higher than 7, we can say that these two variables have a very strong correlation or strong relationship. Okay, and some example here. For the positive correlation, the example is your height and your weight. So if you very tall, okay, like 180 something, okay, by your biology, you would have a more weight than a guy. And I said it in general, I said in general, for the short guy, they will have a small weight, okay. But sometimes in a we can see it in a reality that some short guy they have a heavy weight, they have fat. So that is an exemption, but in general, okay, these two variable they positively correlate to each other. Okay, for the negative correlation, okay, like hour of study and number of errors in a test. So if you spend your time on your study, you review the concept, you read a lot, so um, you make little error in your test and you get the high score. Okay, for the no correlation, for example, the hair color and the test score, it doesn't mean that if you have a gray hair in your head, it doesn't mean that you are a smart student and you have you can do very well in the test, in your achievement. Uh, there have no relationship between your hair color and your score. Okay, and this is correlation coefficient. It is the stat. It's a figure that tell about the strength here and the direction. Okay, the strength I said already. Okay, if you have like up to 7.7 is a high uh, correlation. Okay, the direction is positive or negative. Okay, like this one. um if you see this table, you can see that when you study a lot, you're supposed to have a high score, okay, in your midterm exam, for example. Okay, and but sometimes it quite difficult, in the form of table to see the relationship between two variables. So we're gonna do scatter plot, okay, for the visual inspection, or we will do the calculation. Okay, and this is the formula. Okay, you can do it very easily in your um, Excel. Okay, um, and you can do this calculation. Okay, and this is the step. Okay, and you can just go directly to the Excel and the column. Okay, and you can do it very easily. Okay, for the regression. Okay, um regression um is based on correlation. Okay, and the purpose is um to make a prediction based on your available data. Okay, so very first step, you need to find out the correlation between a group of variable. Once you have a correlation coefficient, you're gonna decide, okay, for the pair of the variable that have very high uh, correlation coefficient, you will be include in your regression model, okay, and 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 uh, and um, you can model it, okay, so which will be the y, which is the this time won't we don't call y as a dependent variable, but we call it as an outcome variable. And as well with the x, we don't name it as an independent variable in the context of regression, but we will change it to explanatory variable or predictors, okay. um, of course, you can see that they imply about the causal relationship, but I would say that we need to 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 have it in order to make sure that x is the cause of y. You need to have um, an experiment design. Okay, you need to maybe have a control and experimental group, and one you give an x, the other one you didn't give it, and you see the result, so you can say with confidence that x cause y, okay. But for the regression, it's like we base on the correlation, and we base on our theory that an x is the cause of y, okay. But we cannot say with our certainty that, okay, this is the cause, the absolute cause of the y, okay. So this is the equation, okay. So the y here, okay, I change the name to outcome variable, right? And this is the a, okay, the a here is the intercept. What is the intercept? The intercept is the um, point where your regression line uh, cut the y-axis, okay? Um, and the b is the slope of the x, okay? So when you run, if you have a b here and it's significant, it meaning that if you increase x by 1 unit, it will, if they have the positive correlation, okay, so y will increase by b unit, okay. Again, okay, the a is the intercept, okay, and the b is the slope. And when we interpret, okay, we're gonna interpret that if we increase x by 1 unit, the y will increase by b unit, okay. And this is, you can see that from the model, we have only one predictor, so we call it simple linear regression or simple regression, okay. But if you have more predictors, I already told you that. If you have oh, this is if you do it by hand, you can do it, but it take a lot of time, okay. You need to calculate the slope first and then the intercept, okay. But we're gonna use the software. In this case, we're gonna use Python, okay. We can do this in a blink of the eye. It's take you a second, something like that. uh yeah, this is the final score. Here is the outcome variable, and this is the predictors. We have the three predictors. We have the study hours, we have attendance rate, and we have class participation. And we have to check with our literature or previous studies about if the student they have spend time on study um, a lot. They supposed to they have the high, they can do the test with the high performance, and they attend the class every time, and they get a high score, unlike the student that miss class often. And the participation for the student that they participate actively, they're gonna have a high score. Okay, I try to say that um, at first you need to check with your literature. Okay, and we have to do the correlation metric first, which I will show you shortly, and then you can you can design. Okay, this is the predictors, the appropriate predictors for this outcome variable. Okay, and this is what the equation like for the multiple regression. You can see this is the beta. Okay, here is the intercept. Okay, and beta 1 is the slope for the study out, and beta 2 is the slope for the attendance rate, and beta 3 is the slope of class attendance. And of course, any model, we have an error. Okay, error of measurement, human error, it could happen. Okay, and we need to take it into our model. Okay, and when you read the result, okay, when you read the output, okay, you please check. Okay, please check um, the R square. Okay, the R square, if it's close to 1, is good, because it's meaning for, in this case, to 0.9, 0.99, meaning that your model could explain the variation or the variance of the outcome variable by 99.2%. Okay. Anyway, they have like so many assumptions. Okay, one of the big assumption is that there should not have the relationship among predictors. Okay, like this: study out, attendance rate, participation. All the three should not have a relationship among them. Otherwise, we will facing an issue of multi-collinearity. Okay, so if I gonna it's already in the handout how to test the for the issue of multi-collinearity. Okay, if you face that, you need to remove the highly correlate predictor from the model. Okay, if for example, if you attend a lot and you participate a lot, okay, and the correlation coefficient go up to like 0.7 up, you have to select and remain just one of the two. Okay, so let's do the coding. Okay, we end at the uncover, And we're gonna do the correlation first. So we create a new block of code. Okay, and then it's on your, let me see, on page, I see it. Okay, 7. Okay, add the line on the line number 2 on. Okay, so we're gonna use the iris. Okay, I could not remember. We actually create an object to store the iris data set, but anyway, we can do it again with different name. Iris, okay, and Seaborn load data set and iris, okay, and then we create, okay, an object that contain the result of the correlation. Okay, so we gonna select, okay, we're gonna select by type. Okay, this one I explain you. Okay, by type we're gonna include only number. Okay, okay, you can see that for the iris data set, okay, the number is the float. Float here mean the decimal. Okay, they have a hole with the decimal. Okay, so it called float. Okay, we have four variable that are numbers. Okay, so this one mean that we're gonna select the variable that has a that are number only, and we want select this one because this one is a category, right? Category. So we will select the sepal length, sepal width, petal length, and petal width. Okay. And then we're gonna print it out. Okay. Correlation matrix. Okay. And enter. Okay, let's see. Let's see. Okay, because oop, this one has to be iris. Okay. You see that this one, this is a diagonal. Okay, is 1. Okay, diagonal is 1. Meaning what? Meaning that when they have the correlate with themselves, okay, they will have a perfect positive correlation. And if you observe, you can see that this guy and this guy are the same. This one, the same. Okay, petal length and petal petal length and sepal length, the relationship. Okay, the relationship here, this is the petal length and sepal length, and this one, this one, this one, this is a sepal. If you look on the your left side is a sepal length and petal length, the same pair. Okay, they get the same number. Okay, so in correlation study, okay, you need to put this in your report, but you don't need to you know, put everything. You can just leave, okay, you can just leave the upper triangle, leave out, okay, and you can show just only the lower triangle, because uh, the number or the value are exactly the same for the same pair, okay. And if you want to create the visualization, okay, of the correlation matrix, okay, before we go to the visualization, I would like you to check this. Okay, petal length and sepal length. Okay, sepal length and sepal length. These two, they have a high positive correlation. Okay, and the same as the petal width and sepal length, they have also have a high positive correlation. Okay, and I will say I will put it into my model. Okay. um Next, I will create the visualization of the correlation matrix. Okay, and we call that visualization correlogram. Correlogram. It's like a heat map. Okay. Um, you see. Okay, so we need PLT figure, and we can set the size 8 by 6. um this is the y and the long of the the rectangular for the heat for the parallelogram. Okay, and okay, so the heat map, okay, it has to be built based on correlation. So you need to do this first, okay, and you put it in the Seaborn heat map and M not true and CMAP cool warm. This argument is just for to make it look more cool or beautiful. Okay, you can change this to any color of your choice, but this is, you know, very commonly and generally used in the paper. Okay, and you need a title, a title, PLT title. Okay, so this is the communication. So I think the visualization need a title. Okay, so we will call it correlogram of the correlation matrix of the iris database. Okay, and we need to ensure that the correlogram it fits in the area that we specify, which is 8 8 by 6. Okay, so tight layout, and I think we are ready to run. Okay, so this one. Okay, this one. So you can see that this is the heat map. Actually, you don't need to show the all of them. Okay, you just show them just the lower triangle. Okay, this is the diagonal because these two the same. This the same, right? This the same because it come from the same pair. Okay, so but anyway, you can leave, but this one, okay, you need to retain this because this would help you interpret. Okay, you see that the maximum, which is the dark red, is the positive, right? But for the purple, the max is um, minus 0.4. Okay, so it is low negative. Okay, not high negative correlation. Okay, and most of it has a strong positive correlation. You can see that it is red and dark red or orange somewhere here. And for this one, okay, this one have a very small negative correlation. Okay. Okay. And now this is uh, the number shown here is correlation coefficient, but we don't know yet whether it's significant statistically or not. So we need to test it. Okay. So I will zoom out. Okay. Now, we're gonna test correlation significant. It's on page 17. Okay, it's on page 17, and on the line 17. Okay, we need to give a comment first. Okay, test correlation significant. For this time, we will test the correlation between sepal length and petal length. Okay. If we look, from the either from the correlation matrix or the correlogram, okay, you see that the sepal length is here, the petal length is here, so the coefficient is about 0.8717, which is very high, but we don't know whether it it significant or not. It's just a correlation. Okay, so we need to test test its significance. Okay, so we have a R, which is the correlation, the coefficient. Okay, and we have a P, and we have stat, Pearson. Okay, for let me just review you. There are many kinds of um, statistic for to do the correlation. Is depend on the level of measurement uh, of the interested variable. If both of them they are ratio, okay, the type of stat for this kind of data is Pearson. Okay, but if you would like to correlate the variable with different level of measurement, you need to go for maybe point by serial or Spearman rank, something like that. Okay, but for this one, this is the ratio. Okay, they have the absolute zero. Okay, and df iris, df iris, and we're gonna pick um sepal, sepal, sepal length. Okay, and df iris, we select petal length. Okay, and then we print. Okay, we print again f string Pearson correlation relation between sepal length versus petal length R equal placeholder R 3-fold and for the p-value p for f. Okay. Okay. So let me explain the code. The first one, this one, there are two value. Okay, the R, which is the correlation coefficient. Okay, and the P stand for p-value, and we use that, and we use the Pearson correlation, and we select a pair of variable that we are interested in. In this case, sepal length and sepal length and petal length. Okay, which is hopefully we will get like 0.87. Okay, and hopefully that it will um, statistically significant. We have to wait and see. And okay, we should be fine. We click run. Okay, so yeah, so we have this the same. Okay, 0.872, 0.872, 0.872. Okay, because we allow them to have just 3 decimal, 3 point of decimal, so they will round up. Okay, 7 round to 2, so 872, 872, and for the p-value is lower than the alpha of much less than the alpha of 0.01, so it's significant. Okay, it's significant. Okay, we have done with the correlation. Okay, so let's move to the last part of today, which is um, regression. Okay, please okay, please please turn on page 18 on line number 11. Okay, line number 11. We're gonna use tip again. Okay, so you turn your hand out on page 18, and you go down to line number 16. Okay, we're gonna work on that. Okay, we're gonna start with the tip. We won't have this one yet, and we're gonna load it. Are you tired, exhausted, you get bored? I do understand you have to sit on in front of the computer for 6 hours. You are incredible, and I hope that you get most of the training today. And if you have any question after this, I am more than happy to give you some advice or answer any question. I will leave my personal, not personal, my university web uh, email. Okay, email with the coordinator, and you can ask for my email address from her. Okay, and you are very incredible uh, person. You focus, and you spend your time with me a whole day. I really appreciate. Okay, let's get back to our analysis. Okay, and we will load tips. Okay, and like I said, okay, if you want to do the regression, you need to do the correlation first. Okay, I hope that you can remember. We can just copy this, and change this to um, tips, tip, and total bill. Okay, and for this one we have to change it into tips. This one we have to change it to tip, and this one tip. This one is the total bill. Okay, let me check. Okay, this look good. Oh, this one has to be tip and total bill. Okay, before we do a regression, okay, the model is that we interested in our outcome variable, which is a tip, or how much you give the tip for the weather or waitress, and we're gonna predict it by uh, the total bill. Okay, and our hypothesis, um, based on logic, if you have a very you pay a lot for your bill, you're supposed to tip a lot. Okay, but if you have like a small total bill, you can just give a little bit amount of money as a tip for the waiter or waitress. Okay, this is the hypothesis. Okay, but first we before we do a prediction, we need to do the correlation first. Okay, so we need to check, we need to find, okay, the correlation coefficient between two variable, which is tip and total bill, and then we have to check whether this coefficient um, is significant or not. Okay, so yeah, it's quite strong, right? It's quite strong. So the is a positive, right? It's a positive correlation, and it's significant. Okay, scientific no, statistically significant. Okay, you can see that the p-value is much lower than our alpha set at 0.01. Okay, so we can move on. Okay, we can move on to the regression step. Okay, okay, we're gonna have no, I should write it after this. Create model. Choop, choop, choop. Simple regression. Okay, and we need to have a model first. For the simple regression, I name it model 1. Okay, and we have SMF. Okay, dot OLS is it stand for ordinary least square. It's just a technique in the regression. Okay, and I have to put the model inside the quotation mark, which is tip and tutor and total bill, and I need to tell them about the data I use. I use DF tape, and I have to fit this model to the data. Okay, and okay, I think I need to import import. Yeah, it's already in your handout. Okay, online Um, number 12, we need to import stat models formula dot API as SMF. Okay, stat model formula. Okay, as SMF. So no longer have the wavy line under S and F. Okay, and then what I'm gonna do? I'm gonna print. I would name it as a put enter and a simple regression. Simple linear regression tip and total bill. Yeah, and then I will print. Okay, print the result. Okay, um actually we have the coefficient and it's significant. Okay, so it's a sound argument to put it into the regression model, okay, as a predictor. Okay, I think it should be okay. I click run. Okay, so this is the correlation coefficient, and this is a p-value that we have done previously, and this is our model. Okay, this is the linear simple linear regression. Okay, it's a long output, but anyway, I will teach you. Okay, I will teach you where to look at. Okay, where to look at. At first, you see the F statistic. This is mean that overall of our model is significant or not. Look at over from the overall, the top eye view, okay, for the whole picture, okay. So our model, okay, for they have a F values, right? Is 200 something, and F this one, okay, it's a F statistic, okay. You see that is E minus 34. So it is very small amount, so much less than the alpha at 0.01, meaning that overall, okay, our model is significant. So it means something meaningful. Okay. The other part, these two, okay, you need to look first the F statistic and probability of F statistic. Okay. Check whether it's significant, and then you look at this, the R square, meaning that the total bill, which is the only predictor in the model, they can explain the variance of the total the tip, the total bill. Okay, they can explain the variance of our outcome variable, which is the tip by 45%. okay, by 45%. You see that we just add one predictor and we can explain the outcome variable this much. So I think we are um, we are pretty, we are pretty good because we test first. Okay, we test the correlation and we pick one with the quite strong positive correlation and we put it into a regression model. Okay, and okay, so let's interpret this. Okay, at first, please look at this. Okay, this is the p-value and you can see that it less than our cutoff or alpha at 0.10 is much less than that, so it's statistically significant. Okay, but the way you interpret, okay, you need to be very careful. Okay, so this one mean that, okay, this is a tip. Okay, the tip without without the effect of total bill, meaning that um, if if regardless of the how big the total bill is, you will get on average like 1.9 unit. Okay, 1.9 unit. But this intercept mean that is a line that cut at the point of y-axis, and the y-axis here represent the tip. Okay, when we interpret, we have to interpret line by line. Okay, for the intercept. Okay, regardless of how big, if I pay 1,000, 10,000, or just 500 baht, okay, without that effect, on average, I will get tip at zero point 0.9 unit. Okay, but if we include the effect of the total bill, meaning that if I increase the total bill by 1 unit, okay, I will have my tip uh, increased by this amount, by this much, okay, by 0.1050, meaning that you can calculate like 1.9 something plus 1 0.105, something like that. Okay, this is how you interpret. Okay, so for this one, without any predictors, on average you get the tip at 0.9 unit. Okay, but if you take the total bill into your model, it has an effect, meaning that um, meaning that if you include into your equation or your model, okay, they have an effect and positive effect. Okay, meaning that if you increase the total bill by 1 unit, okay, you will have the intercept, which is a tip, increased by this much. So you just add this to this, so you will get that amount of tip. Okay, this is how to run and interpret the result. Okay, we have time for the last topic, which is the multiple regression. Okay, but I have no worry at all because we have passed the very core concept. Okay, multiple regression. Okay, it's on the same page, okay, 18, and you go down to the line number uh, 24, okay, 24, okay. So this is the model 2, and SMS, okay, the model is inside the quotation, okay. Our outcome variable is still the same, the tip, but now we're going to increase the number of predictors. So that's why we call it multiple regression, multiple linear regression. So this time we're going to have total bill plus size. Okay, size mean how many people on that table. Okay, how many side of uh how many side of how many people on that table. It is the meaning of the variable size. Okay, so if you have high value of size, meaning that there are more people on that table. Okay, and we have category sex. So this one, we would like to know whether male or female effect being specific gender will be treated uh, better on or not. Okay, and okay, the data the data is the DF tips fit. Okay, so yeah, it's clever. Yeah, it's clever. It's automatically typed for us, and don't forget to check. Okay, don't forget to check. Okay, it's look all right. Okay, it's tip regress on total bill, size, and sex. Okay, and we're gonna print it out. Okay, module 2 summary. Okay, okay, okay. Okay, what should we look first? This is the output. What should we look first? We should look at this, right? For the whole picture, for the whole model. Okay, and we have to look at the p-value, which is here. Okay, you see, it's a e minus 32. Actually, it means 1.11 multiplied by 10 power plus 32, meaning that you have like 0.000 31 zero and then 111. So it's highly significant. Okay, so we should be happy. Okay, and this one, okay, this is how much um, of the model could explain the variance of the outcome variable, which is tip. Remember this round, we add two more. Okay, we have size, and we also have sex in addition to the total bill, right? Okay, last time we have about 45 but this time out, we have like up, we can round it up like 47. It's not much. It's not much. But we will see. We will see. You can see that. You can see this one, this one, this one. Okay. You can see that this is a p-value is higher than the alpha set at 1 no 0.05. Okay, this one is not significant, not significant. Okay, so it interpret as being a male or female, you get the same amount of tip. Okay, regardless of your gender. Okay, and over here, over here is the intercept, meaning that this is your tip. Okay, when we control other predictor or keep our predictor as a constant. Okay, we will have an average like 0 65. Okay, and this one total bill, total bill um is significant. Okay, but quite low. Okay, quite low effect. Okay, as I told you that the strong correlation should be from 0.7 up, right? But this one less than 1 point, less than 0.1. Okay, so very small effect. Okay, that is why we can overall explain by just 47% compared to the simple regression. We can compare by 45%, so not increase much. And for the size, okay, for the size, it is it is 6, right? Okay, it's depend. Okay, it's depend, but this one it is a study of social science, so we set our alpha at lower than 0.05. So this one still lower than the alpha is lower than the p-value. Okay, so it's 6, significant. Okay, so yeah, the size is about 0.2. So when we interpret, okay, we interpret like this. For this one, for this one, if we increase the total bill by 1 unit, the tip will be at this much on top of 0.6. And if we interpret this, we have to ignore other predictors or keep it as a constant. Okay, so if we increase the size by 1, okay, increase size by 1 unit, meaning that your tip, okay, will go from this much by this unit. Okay, by this unit. Increase this by 1 unit. We increase y by this unit. Okay. The problem, you can see some problem here. And I remember that I suggest you to do the correlation first. Okay. But for the multi regression, I skip that step, which is dangerous because these two guys, the total bill and size, this is the two predictors that have a positive relationship and very high positive relationship. You know, if you have 10 people, you pay a lot. If you on that table, you have you and your boyfriend or girlfriend, you have just 2 people, you have a total bill less. So these two they violate the assumption of regression, of multi-regression, because these two predictors they correlate to each other. So you are facing an issue of multi collinearity. So you need to remove one of the two. You can keep this and leave this out, the side, leave the side out, or you can keep size and you kick off the total bill. It will improve your model. Okay, and that is all. I hope you can follow. And I look at the chat, and the coordinator said that this training is recorded, okay, and it should be ready for later watching in 5 days, right? So thank you so much for your attention, and I hope that you will have a lot of success in your career or in your study. Thank you ครับ สวัสดีครับ
Dr. Pongprapan, for your insightful and practical presentation today. Your session has provided us with the techniques and perspective that we can apply to improve the quality of our research. And we would also like to express our appreciation to all participants for your active engagement and contribution throughout today's training. Before we officially close, we kindly ask you to take a few moments to complete the feedback survey that by clicking the link that we provide in the chat box. And your comment and suggestion are very important to enhance the future training session. And once again, thank you to Associate Professor Dr. Pongprapan Pongsophon for sharing
Thank
your
you.
expertise. And thank you to everyone for attending today. We hope to see you again in our upcoming training. Have a wonderful day ahead, and please don't forget to fill out the feedback form. Thank you and goodbye.
Bye bye สวัสดีครับ Thank you so much